Hi, this is Phil Howell, the Director of Teaching and Learning at the DePaul School. I want to show you a method we've been using with many of our students to help them quickly learn to subtract multi-digit numbers. Many of our students have struggled for years to master multi-digit subtraction. They find the traditional approach, known as borrowing, to be very inconsistent problem to problem, visually confusing, and hard to remember over a long period of time. The approach I'm going to show you has cleared up many of these issues and has allowed them to move on to more advanced mathematics more quickly. We want you to be familiar with this approach so you can understand what your child is doing on their homework. Much of the difficulty students have with the traditional approach stems from how different the method looks from one problem to the next, and even within a single problem. You'll notice, for example, that in this problem, some numbers are being crossed off and replaced with greater numbers, while other numbers are being crossed off and replaced with lesser numbers. Now, we may understand why this occurs, and we can explain it, but visually it is inconsistent from one problem to the next and can be confusing. As I'm sure you're aware, zeros can be a particular source of confusion for students. Sometimes a 0 will become a 10. Other times it becomes a 10 and then becomes a 9. And then in other problems, both of these occur. It's these visual inconsistencies that are causing our students to become confused, even when they understand the rationale behind these steps. Now let's look at the new approach. Now this video will only show what the method looks like on paper. In a separate video, we'll show the concepts behind why this approach works and how we teach those to children. Like the traditional approach, we begin by subtracting in the ones place and then move to the left to each higher place value. But when we reach a point where subtraction can't occur, such as 6 minus 7, this is where we see the difference in these approaches. We simply write two numeral ones. We write a 1 in front of the 6 in this example to make 16. And then we write another numeral 1 in the next place value. We'll subtract that extra 1 when we get to that point in the problem. Now we can subtract in the tens column. And we move to the hundreds place where I see that I don't have enough hundreds. 2 minus 1 minus 3. So again, I write two numeral ones. 12 minus 1 minus 3, many of our students here would say 12 minus 4, equals 8. And in the thousands place, I have 3 minus 1 minus 1, which is 1. Now notice how consistent the look is throughout this problem. Students are only adding numeral ones, and the digits across the top are only becoming larger by 10. They're never being replaced by lesser numbers. This method always works the same, no matter what the numbers are in the problem. Let's look at zeros, for example. When I can't subtract, I write 1, 1. When I can't subtract, I write 1, 1. When I can't subtract, I write 1, 1. Now, no doubt what seems different to you is the need to subtract that extra 1 in some of the columns. Students get quite used to this early on because before they learn the written procedure, we teach them the concept behind these steps, and it makes complete sense when they go to paper. We'll show that explanation in a separate video. Let's run through two more problems. Try pausing the video and solving these yourself. This procedure is one example of the many ways we strive to teach the way your child learns. If you have any questions at all, please contact your child's teacher at 502-459-6131. Thank you so much.